Three variables. Yesterday we talked about two variable systems where we had like two lines that we were looking at where they intersected. And then we had a couple examples of like a parabola and a line or a circle and a line. Okay. Now we're going to move to three variable systems. Once we add a third variable in, we no longer have lines, we have planes in three-dimensional space. Okay. So you guys have worked with three variable systems of equations before. Okay. But I wanted to review what it meant. Okay, we're still finding where they intersect. So oftentimes we're going to find one point where these planes are intersecting. Okay. It is possible for us to get infinite solutions. Okay. Here are the two types of infinite solutions where we are intersecting at a line or we're all just the same plane. Okay. We are actually going to look at what this looks like algebraically today. That's something that you haven't gotten to do before. Okay. Or our three planes aren't going to intersect at all. Okay. Here, there's a pair intersecting, but not all three of them are intersecting together. And then here, they're all three parallel. Okay, so these are the two different no solution possibilities. Okay, but what we're doing is we're taking three planes and we're trying to find where they intersect. Okay, so let's just get started. Let's write it down. Okay. Let's talk about our strategy to solve this. Does anybody remember the strategy you used last year in Algebra 2 to solve these? Do you remember stating these? Okay, what we're going to do Okay, we are going to eliminate one variable twice. Okay, so we're going to take this three variable system. We're going to eliminate x, y, or z two different times. That way we can get it down to two equations of two variables. Okay, we are rock stars at two equations, two variables. So if we can do some elimination to get two different equations with just two variables, we can solve for those two variables and then plug those back in to our original. Okay, so if you look up here, which variable would you like to choose to eliminate two different times? Z, how do you guys feel about Z? Set up pretty nicely for us, right? Okay. So what we can do is we can take the second and third equation, right? If we take the second and third equation, 2x minus y plus z equals 3, and 3x plus y minus z equals 2, what happens when we add those together? What do we get? Oh man, 5x equals 5? That worked out way too nice for us, didn't it? Okay, now we already chose to eliminate z, so let's eliminate z again. What I'm going to do is I'm going to box this so I know I need to come back to it. Okay, so now let's pick a different pair of equations to eliminate z. Which pair would you like? First and third sound great. So we have x plus y plus z equals 6, and 3x plus y minus z equals 2. So when we add these together, what do we get? 4x plus 2y equals 8. Okay, so now we have two equations with now only two unknowns. So let's write what we have. We have 5x equals 5 and 4x plus 2y equals 8. What should we do to now solve for x and y? Okay, so we can say that this is the same thing as x equals 5, right? X equals what? 1. That would be better. And we can plug that into this one, right? 4 times 1 plus 2y equals 8, which means 2y is 4, and so y is 2. Okay, so far we have x equals 1, we have y equals 2. How will we get z? Okay, plug it back into one of the first ones. Doesn't matter which one. Kyler would like the first one. It probably is the easiest because there's no coefficient. So we have x plus y plus, what is it? Z equals 6. So what is z? Okay, so our answer is the ordered triple 1, 2, 3. Okay, now we did a lot of work to get that answer, didn't we? Okay, you can know if you got the right answer or not. How do we know if we got this right or not? We can plug it back in. So let's look. Is 1 plus 2 plus 3 6? Is 2 times 1 minus 2 plus 3 3? Excellent. Is 3 times 1 plus 2 minus 3? Is that 2? Excellent. Then we did it right. We have the right answer. This coordinate is where those three planes intersect. Okay. When you are going through your algebra, please be very careful. Okay? These are not difficult problems. What makes these seem sometimes difficult is when you make a simple arithmetic mistake and it throws everything off, right? If we were to add, if I were to say, you know, I accidentally wrote x equals 5, everything else would have been wrong, right? That was a very simple mistake, easy to avoid, right? So just take your time, be very careful, okay? I am assigning you some odd problems for these so that you can go back and check your answers, okay? Look at this one. Okay, so what's nice about this one? Okay, in this equation, we are already missing a y. So let's use that to our advantage, okay? Let's take the other two equations and eliminate y. In order to do that, what should we do? Multiply the first one by I would do -3 to make the y's opposites, right? So in that case, we have -6x minus 3y plus 9z equals -12. And then here's our third equation. What do we get? Minus 4z equals -20. So now what we can work with is we have 4x plus 2z equals 10 and -8x minus 4z equals -20. Now let's solve this one. What's happening? If we multiply this top one by what? Just 2, because we already have opposite signs. We get 8x plus 4z equals 20. Our second equation is -8x minus 4z equals -20. We get 0 equals 0. Which means there are an infinite number of solutions. Okay? Now, when we only had one line, or excuse me, when we only had 2 lines in a plane, we could say, all right, these are the same line. That's what it means. However, when we have 3 planes, we're intersecting in a line. How do I know that it's not one plane? If we were intersecting in one plane, then these would all be able to go to 0 equals 0. Okay? But what's happening is we are intersecting at a line. Now, we can't really write the equation of a line in 3 space. Okay? Do you really want to even think about doing 3-dimensional slope? No, that sounds awful. Okay? We actually need a little bit more knowledge to be able to think of 3-dimensional slope. So what we're going to have to do is we're going to have to write a relationship. Okay? There is a relationship with all of these points because they lie on the same line. Okay? We're not going to worry about what the slope is. We're going to worry about what the relationship is. Okay? So if you get to a point where you have an infinite number of solutions, what we are going to do is we're going to write a coordinate in terms of a variable a. Okay? So these all are going to have a relationship because they are on a line. Okay? So what we're going to do is we are going to pick a variable to be a. Okay? So since we're down here and we have x's and z's, I'm going to pick one of these to be a. Right? Does anyone have a preference? X? Somebody else? Okay, doesn't matter. It's not going to matter as long as we have a relationship. So if we let x equal a, then we can come back to this equation right here and say that 4a plus 2z equals 10. Which means 2z equals 10 minus 4a. Which means z is what? 5 minus 2a. And so then, how do we find y? Plug those in. I'm going to pick the top equation because it doesn't have a coefficient for the y. So our top equation is 2x plus y minus 3z equals 4. So we have 2a plus y minus 15 plus 6a equals 4. So we have 19 minus 8a, right? Do you agree with my algebra there? Okay, so we could write this as an ordered triple. A 19 minus 8a, 5 minus 2a. That way, okay, so this is describing a linear relationship, okay? If we plug in a is 1, we can find a point on the line. If we plug in a is 2, we can find a point on the line. So this is representing an infinite number of solutions where the relationship is linear. Okay, now I will warn you, if you would have picked z to be a, would you have had this same answer? No, your answer would have looked a little bit differently. So if you're checking your answers in the back of the book and you picked a to be a different variable, that is okay. It's just not going to match what the back of the book has. Okay? Questions on this? Does it make sense why we pick a? And we have to describe a relationship, and so this is the most straightforward way we can do it. All right. This is a very important section because we can do a lot of applications with it. Okay. So that's what we are going to practice. So instead of us reading a big problem and you don't write the problem down and then you go back to your notes and you don't know what the problem was, let's just do a book problem. So I want you to turn in your books to page 498 and we're going to look at number 62 all together. Okay, so number 62. Somebody like to read it? Okay, follow along while I read it. A health insurance company advertises on television, on radio, and the local newspaper. The marketing department has an advertising budget of $42,000 per month. A television ad costs $100,000, a radio $200, and a newspaper $500. The department wants to run 60 ads per month and have as many television ads as radio and newspaper ads combined. How many of each type of ad can the newspaper run each month? So first of all, before we do anything else, let's assign our variables. How many variables do we have? 3, Grady. So x, y, and z. We can let x be what?
Number of television.
Okay, number of TV ads in a month, right? Y? And Z. Okay, information. How much money is in the budget for advertising? $42,000 in a month. So, what can we do with that? Okay, now X is the number of ads. Y is the number. Okay, we're talking about money.
So it's 40,000 times X. Plus 200 plus 5.
Equals 42,000. Okay, so one equation is our budget. Okay. Next piece of information, the department wants to run 60 ads per month. Excellent. And then they want to have as many television ads as radio and newspaper ads combined.
Could be Y plus Z X.
Okay? Newspaper and radio combined needs to be the number of TV. All right. We got to solve for these three variables. What would you like to do?
The bottom
You want to do the bottom two? Okay. And what are we eliminating?
two. Could we eliminate the Y from the Z's by
Yeah, now what are we going to have to do with this equation before we go any further? Okay, so are you okay with me, there we go, writing this as negative x plus y plus z equals 0? Does that mean the same thing? If I subtract that over? Okay, so now if we pick the bottom two equations, what can we eliminate without having to do any work? X. So if we pick x plus y plus z equals 60, negative x plus y plus z equals 0, we get this nice equation of 2y plus 2z equals 60. Okay, save that for later. Now what? We need to eliminate x again. The first and the third. Okay, so if we use the first and the third, okay, so we can take first and we're going to take the second one times 10,000, or 1,000, excuse me. Okay, so what does that leave us with? All right, and that is what we get to work with. Okay, so now we're down to the green. Two equations, two variables. Suggestions. Suggestions. Okay. What would you like to solve for? I'm guessing in this one right here, right? We can divide by 2. So y plus z equals 30. Okay, so y equals 30 minus z. So then we can go over here and say 1200 times 30 minus z plus 1500Z equals 42,000. 1200 times 30. Good. 36,000 minus 1200Z plus 1500Z equals 42,000. Okay. So, how many Z's do we have? 300Z equals, when I subtract 36,000 over, what? And so what is Z? 20? And if Z is 20, we can come back over here, and what does that make Y? And then if Y is 10, we can come back over here to the Y plus Z equals X equation. And what would that make X? 30. Okay. Now, do I want your answer as 30, 10, 20? No, Kyler, how would I want you to write it?
10 times 20. No, it's 30 times 20.
Read the problem. What do they want to know?
30.
30 TV ads. 10
Regular.
and 20 it's a good thing that we assigned our variables up here. That way we knew what our variables meant when we actually solved for this. Okay. Please make sure on a word problem you give me your answer with a label. All right, so you have a few minutes to get started. This is your homework. Now, 39 and 41, those, I believe you will get some infinite solutions. Remember that you will, if you pick a different A, your answer is going to look different, and that is okay.
Well, are you going to hear back the midterms, or?
When everybody takes it. Okay, I'm not going to go over them until everyone takes it. So, it'll be a couple days yet. All right. Hopefully you can get at least a problem done before you leave. That would be your